Hello, Accelerated Math 7-8 students, and welcome to our 5th video. I'm opening to the table of contents, and your video that you're focusing on tonight is equivalent ratios defined through the value of a ratio. Yesterday we talked about the associated ratios with the value of a ratio. Now you're looking for equivalent ratios defined through the value of a ratio, and you find that on page 17. Okay? So I'm going to turn in my comp book to page 17. So here we are. Okay. So again, equivalent ratios defined through the value of the ratio. Boys and girls, I need to reiterate, every time we turn a page, you have to write the title. I've been checking your notes, and several of you are forgetting to put the title on the next page. Please, please, please put the title on each page that you use for your notes. The goal: today we are going to learn how to use the value of a ratio to make and find equivalent ratios. Okay? The question that you're going to be thinking about during this lesson is, how is the value of a ratio related to a ratio? Okay, so we have a ratio. We can find the value of the ratio. Your job is to tell me how they're related to each other. Okay? So the first thing that we're going to do is we're going to show what you know. So this is a little bit of a review to see what you've learned, see what you know, okay? And what I would like you to do is it says, please turn the following ratios into their value of a ratio. And I'm giving you a little hint right here. Think of another way to write a ratio. There's 3 ways, and the value is very similar to one of the ways that you write a ratio. So in your comp books, you need to make a column for the tape diagram, you need to make a column for the ratio, and you need to make a column for the value of the ratio. And I am going to show you them one at a time so that you can create them. All right, so here's the first one. If I show you this tape diagram, and let me move it so you can actually see it pretty well. So there it is right there. It's kind of hard to see. Let me get it a little bit bigger if I can adjust my screen a tiny bit. Let's see. I did learn this a few minutes ago. We're making the screen bigger so you can see it. There we go. It's not working on the dial, so it's working on here. Okay, so here's our tape diagram. Everybody right now, please write that as a ratio. Okay, hopefully all of you put 1 to 2 because you have 1 to 2. Okay, what is the value of this ratio? Remember how we learned it. What is the value of the ratio? That's your job, okay? All right, next one. Here is your, oops, I don't want to show you the ratio because then you don't have to think. Here's the tape diagram. Oh, here is the ratio. Ooh, that one's a little trickier. How in the world does the tape diagram look like that, but now the ratio looks like that? Well, you'll have to answer that by telling me what the value of the ratio is, okay? Next one. Same tape diagram, 6 to 12, what would the value of the ratio be? And the last one, here's your tape diagram. Here is your ratio, 12 to 24. What is the value of the ratio? All right, hopefully you all can figure that out because this is a review because you should know that because we covered it. Okay, I'm going to zoom it back out so that you can see. We will have the answers to those on the board tomorrow. What do you notice about all of these ratios? 1 to 2, 5 to 10, 6 to 12, 12 to 24. What do you notice about them? Okay, might want to look at the title to give you a hint. Okay, the next thing that you have to answer is, what do you notice about the value of the ratios? So when you figured out what the value was, what did you notice about them? There's something that is very interesting about these value of ratios. What did you notice about them? Okay? All right, so that was our review. That was to show what you know and that you understand value of the ratio. Now, kiddos, we are getting into new information, and we're going to, again, figure out equivalent ratios defined through the value of a ratio. So let's see how that works. Here's my question that you have to answer. Does 1 to 2 mean the same thing as 5 to 10? Okay, well, let's look at it. does 1 to 2, so this means if we're doing a value of the ratio 1 to 2, here's our ratio, the value of that ratio is a half. If we have 5 to 10, the value of that ratio is 5/10. Can 5/10 be simplified? And if you said yes, you are correct. It can be simplified to 1/2. Oh, wait. Does 1 to 2 mean the same thing as 5 to 10? Doesn't mean the same thing. And the answer would be yes, because they're equivalent values. All right, so let's look at the next one. What is the value of 1 to 2? 1/2, we just covered it. What is the value of 5 to 10? 5/10, which can simplify to 1/2. So then the next question is, do 1 to 2 and 5 to 10 have the same value? What is the answer, boys and girls? The answer is yes. So what could we say about these ratios right here? We could say that the ratio of 1 to 2 is equivalent to 5 to 10. So you just proved that 1 to 2 is equivalent to 5 to 10. And that's the title of our lesson today. Equivalent ratios defined through the value of the ratio. So as long as their values are the same, what does it mean that the ratios are? It means that the ratios are equivalent. Okay? So basically, we checked their values. Values are the same. That means that the ratios are equivalent. Okay? Everybody understand that? All right, so now your job is to try it by yourself. Okay, so here is a give it a try for you. Okay, the give it a try says, for every 3 potato chips Mrs. Nelson eats, you've all seen me eating potato chips and oatmeal. For every 3 potato chips Mrs. Nelson eats, she drinks 1 sip of water. What is the ratio of consuming things? Yes, I consume things. Consume things means to eat or drink them. Okay? So what is the ratio? The ratio of this little scenario about me eating chips and drinking water, that's what you have to find first. And then you need to also tell me the value of the ratio. Okay? All right, and then the last thing that you need to know, and this is very important, so I need you to write it down because this is like the ending of our lesson. Equivalent ratios are not the same numbers, but their values are always the same. Let's go back to this to help us understand that. Equivalent ratios are not the same numbers. Are these the same numbers? Nope. They are not the same numbers, but their values will always be the same. So what you need to know is that equivalent ratios have different numbers, but same values. Okay? If their values are not the same, they will not be equivalent. Okay? If their values are not the same, then they will not be equivalent. An example of that is, what if I go back to my 1 to 2, and then what if I say my other example would be 2 to 6. Okay? So the way we check is we have to turn this into the value. How do you take 1 to 2 into its value? 1 divided by 2. Okay? And this one would be 2 divided by 6. So this is 1/2. What can this simplify down to? That is correct, 1/3. Uh-oh. Are they the same? Nope, they're not. So if they're not the same, are they equivalent ratios? Nope, not equivalent ratios. Okay? So that's the whole lesson in a nutshell. Does everybody feel comfortable with that? I sure hope so. Okay? So let's go back to our question for the day. How is the value of a ratio related to the ratio? You should be able to answer that. And what I'm looking for tomorrow on our board is you need to have given me all of the values of the ratio for the review. You need to answer the question that you notice about these ratios. You need to answer the question that you noticed about the values. One hint, simplify your values. Simplify your values, okay? And then on this side, I think we answered them all together on the scratch paper, so I think we're okay. The potato chip one I want you to do. So you need to give me the ratio of the potato chip story and then also give me the value of the potato chip story. All right, kiddos, that's it. We're finished. I will see you all tomorrow. Have a good evening. Bye.